Hey, Math 1, I've got a new lesson for you. It's 3.3. It's all about compound inequalities. So before we dig into the examples, let me just give you guys a bit of context so that you can think your way through this without just blindly calculating stuff. So compound inequalities are basically they're the solutions to two simple inequalities, or single inequalities. So if you look at examples 1 and 2 on your notes, 8x plus 2 is greater than 12 is one simple inequality. 22 is less than or equal to 8 minus 4x is another one. And they're generally going to be separated by two conjunctions, either or and. So when you see and versus or, they're both telling a very different story. And means one way to think about it is what the two solutions share. What the two solutions share. That can also be interpreted as the intersection of the two solutions. So, and means intersection, where they meet, what they share. Let's see, can you guys see that? We're barely, okay, intersection. Another way I've seen it posed is to say it's a combination of the two solutions. And means combination of solutions. So in a sense, it means if we were to say x is greater than negative 2 and x is less than 1, what you're doing is you're saying, what do those two solutions look like on a number line? Well, the x is greater than negative 2 looks like an open circle at 2 and everything to the right. 1 looks like an open circle at 1 and everything to the left. So if it's an and statement, you're being asked to say, what do those two solutions share? What's the intersection of those two those two graphs, okay? What's the combination of those solutions? Well, I think if you look at it from the perspective of what do they share everything in between because that's where both of them exist at the same time. Where do they intersect? In the middle, all right? What's the combination of the two? All the stuff in the middle. So your final answer would be an open circle from negative 2 to 1 where you just shade in between. And that's what that graph would look like if we're talking and situations. Okay? Now if we're talking or situations, or means the union of two solutions. It means make sure that you graph every element of both solutions. So, or means graph every element. So every number. Sorry, I didn't leave enough space here to really separate these. And that looks different. Here's an example of an OR solution. So you guys might have to put this somewhere else on your notes. Sorry. Let's say you've got x is less than -1 or x is greater than 3. Okay? Situation like that. So you'd have an, you know what? Let me put equal to so that we've got some representation from both parts. Yeah. So I would put a closed circle at -1, and less than or equal to means everything left of it. When I graph x is greater than or equal to 3, closed circle at 3. And it would be everything to the right of 3. Now, when you see OR over here, it means the union of the two solutions, which means graph every single element of both solutions. So you're not going to graph everything in between. You're going to say, all of these represent elements from the solution, all of these represent elements of the solution. So what you do is you just leave it as is, and that represents your final graph. All right. So with that knowledge in hand, you guys are probably ready to start through the examples. I'm going to stop the video so that there's a clear distinction between this is the stuff you need to know to make sense of it, and then the next video will be all the examples of things that kind of have the practical use of what you guys will be doing on the homework. All right, thanks for watching.